Hello again, this is Mark Summers from Summers Technical Services. We're going to take our Dash 29 part that you've designed in class and see if we can make some Mastercam tool paths so we can cut your aluminum part on the HAAS 3-axis CNC mill. So I'm not going to go through all the steps, just kind of go through a few of them to get you familiar with how to build these tool paths, and we'll see where we go. So let's get started. So here I'm in Mastercam 2025. I've got my part model already designed, and so I'm going to plop it in here and use that for my geometry. So I'm going to use I'm using my cheat sheet over here I've got on my other screen for my little Mastercam tips that I posted on Canvas for you. So let's see if I can go find it over here. Yeah, Mastercam tips. All right, these are just general tips. I'm going to go through them in order here. So the first thing I want to do is merge my SolidWorks part into Mastercam. So I'm going to go to my pull down, file, merge here, and I'm going to go browse and find my SolidWorks part I designed. My part will look different than yours because you did your own design. 3316 project. My files are all in here, and I'm not looking for Mastercam files. I'm looking for SolidWorks files. So this looks better. Go down here and find the Dash 29 part right there, and we'll open that up. So now it's plopping in here, and I'm going to just accept it, say OK. So now my model is in Mastercam. However, when I do these views, I'm going to look down from the top. I'm expecting this part to be facing up at the top, so I'm right clicking to get these views. I need to rotate this thing, and I need to spin the window around into the view that will let me look into the axis of rotation. So I want to be looking into this x-axis. So I'm going to right click, and I believe I want to do a right view. And there it is. So now the axis is coming right out at me. So now I can use my transform button, which is the next item on our tip sheet over here I gave you. So we're going to go to transform, and I'm going to go to rotate. And I've got to just answer the questions as it comes up. It says select entities to rotate, so I'll select it and say in selection. Now I'm going to come over here, and I don't want to do copies. I want to do a move, and I want one of them. And I can tap at an angle, or I can just spin this thing around, I think. So let's see what happens here. There we go. So I'm spinning it around. Snaps up at the top, so I'm going to click and let go. That gives me my 90 degree. I think that's what I want, so I'm going to say OK. I can check this box and continue in the command, or if I hit the green check box, it takes me out of the command. So I'm going to right click and go back to isometric. And I think that's it. This thing is looking down. If I look down from the top, actually that's not what I want. This is my top of my part, so I got it exactly 180 degrees out of whack. So I'm going to go back to the right plane, and I need to spin this 180 degrees. So I messed that up. So let's go try again. Transform, rotate, select entities. Boom, I selected it. In selection. And I'm going to want to rotate this thing 180 degrees. I want to keep rotating. Is that what I want right there? Another 90 degrees. 180. Prove that. Right click, isometric. There we go. That looks better. So now my top view is looking down on the top, and I see my cut. This is the side we're going to be doing on the HAAS. So we're going to make this pocket. We're going to drill through holes here. We're going to come back with our counterbore tool, and we're going to drill these through holes on this side because we want to do those before we take the part out of the vise. Even though those are countersink holes, we'll drill through holes on the HAAS, take the part out of the vise, and then go take it to the manual mill and come over here and do these 4 countersinks. The holes are to be located. We'll just need to locate the tool on the manual mill to do the countersinks. And then I've also got a little hole here for a temperature probe, so we'll drill that from the top side as well on the HAAS. So I'm going to go back to isometric. As we're moving these views around, I like to keep track of where my construction plane is. So I'm going to go to planes, and I want construction plane to be on the top because I want to define my top of stock on the top. So that looks fine. I'm going to go back to tool pass, and I'm going to look at my axes. I'm going to right click and go to a right view. It looks like that there's the top of, there's a Z, there's a vertical top of stock edge, and the axis is going right through the middle of the part. So I think I'm in good shape with my part orientation. I don't quite know what all this geometry is here, but I want to delete all this stuff just because it looks like extra fluff. I don't want to grab that. I want to grab my part. I want to grab over here. And as long as I make my window not completely encompass the part, it'll just grab stuff that's within my window there. So I think I've got rid of all the residual. There's something over there. Get rid of all this residual geometry. I'm not sure where it's coming from. And if you watch this video and you see something I'm doing dumb, add a comment down there so we can all learn from it. All right, so maybe this is good. I'm going to go ahead and save this thing since I got something good here. File, save as. And I'm going to go browse over to my documents folder. And there's that, and there's that, and there's that. And I'm going to call this, I'm going to go into my folder, and I want to call this, there's our file name for the files for this semester's projects. Yours number will be different depending on your student ID and what semester and what campus you're at. All right, so I'm going to save this. This already exists. I'll write over the one I've got there. Or maybe I'll give it a different name. I'll call it new. I don't know what that old one is, but maybe it's something I want to keep. All right, so there's that. So now I've got that saved. All right, so now let's go to the next step, which is I want to define my machine. So I'm going to come up here and go to machine. I'm going to mill, and I've got these default mills. This is the one we loaded up in class. This is our HAAS VFY 2YT 3-axis mill. I'm going to use that as a mill, and so that'll have all the parameters we need. Now I'm going to do what? I'm going to do the stock setup. So somewhere in here, I can go add stock setup by pushing one of these numbers. There it is right there. Open up the properties, stock setup. And now what do I do? Well, let's go look at some of these buttons here. I've got cylindrical. All right, here's anchor points. I want my top of stock to be at the top of this face here, so I'm going to do my anchor point at the top. And I think it's looking for a selection, so I'm going to grab my part. Select that, select stock or mesh to be used as stock, so maybe I can just do that. Select that, hit end selection. And did it do anything? No. Select, in selection. So maybe it sort of got it, so maybe I'll just approve it and see what happens. Did it make some stock? I don't think it did anything. Let's try this button. Select one or more entities. Enter. There we go. Now it grabbed it. So now I'm going to come over here and put my anchor point at the top. It already knows I want it to be a 1.5 inch radius, 3 inch diameter, because that's what that geometry was. And I need to move this thing, instead of Z being negative, this Z needs to be 0, I think. That'll put that anchor point at 0, 0, 0. 1.5 inch radius, height is 1/4. That's based on the geometry. It filled those numbers in. So that all looks good, so maybe now I'll approve that. And now I've got my stock setup defined. All right, so now let's do my first toolpath. I want to do a pocket to cut out for the thermoelectric cooler. So let's go double check my planes and make sure they're still set. Oh, now the construction plane is on the right, so I like to double check this before I do any of my tool paths. So I'm going to double click up here to put the construction plane back on the top plane. And when I go back to tool paths, I can spin it around and still see, yeah, the top of the stock is still 0, 0, 0. All right, so now let's do some tool paths. I'm going to go to pull this down. I want to do, these are all 2D operations. I want to do a pocket, and it's asking me selection method. So I want to do it on the construction plane on the top, and I can select edges or I can select a loop. Maybe I want to select a loop because mine is all connected. So I'm on loop. I want to grab one of these edges. Make sure I get the one at the top here. And it's got the arrow. This is the direction it's going to be milling. And maybe I like that, so I'll say OK. And now I'll pop up into the tool paths window. Let's go to tool. What kind of tool do I want to use? Well, this opening here is slightly bigger than 1/4 inch. And I think I can do all this cutout with a 1/4 inch flat end mill. So I'm going to go down here and click this button, select tool from the library. This is the master library for the standard Mastercam library of tools, and it's got hundreds of tools in here. We're going to eventually have to change these tool numbers to match the tool assignments on the spreadsheet I gave you. But for now, we're going to use this list, and maybe in the future I want to have a custom tool library for the tools we're using just for this project. But for now, we'll go down here and find 1/4 inch flat end mill is what I'm using. You may use something different. I'm going to select that and say OK. And so now I've chosen my tool. Now I'm going to go down through these other parameters. Some of these we'll use, some of them we won't. We'll go to the first one here, cut parameters. I think I want to do climb cutting. I want to look at this thing down here. This is another tip on the sheet I gave you as saying, what did I say here? Make sure to go check on this cut parameters. This stock to leave on walls, stock to leave on floors. I want them cut all the way to the geometry I chose. And so I want to make these all 0. So if you don't do that, it'll leave that much material on your part. A lot of these things, it remembers it. The next time we come in here, I think it remembers the last numbers we used. So maybe I'll leave that stuff like it is. Now I'm going to get to choose cutting method. And depending on who you ask, some people say this parallel spiral is the way to go. Some people like this high-speed one. I'm going to use zigzag. Seems reasonable. All these other options here, I'm going to leave them as the defaults. It's because I don't have any reason to change them at the moment, but maybe in the future I can come back and change these. Entry motion tells you how you're coming into the part, and there's lots of options. When I do this as a beginner like myself, I'll leave the defaults like they are, and then later on possibly go back and change them. I want to go down here to, here's a lead in, lead out. This is where the tool comes in to start the cutting. Lots of options here. I'm going to leave it like it is and just see what Mastercam comes up with. If I need to change it later, I will. Depth cuts. We've got a very shallow depth here, but I want to turn these on to show you kind of how it works. So if I don't do this, it's going to try to make the feature in one pass. So I want to have depth cuts. And I want to turn this on. And so my total depth of my pocket is 28 thousandths. So maybe I'll go down 10 thousandths at a time and have one finish cut. Oops, I got 2 dots in there. 0.01. If I could type. So there's 10 thousandths, and I'll do one finish cut. And so that way it'll cut down near the bottom with some roughing cuts, and then that last finish cut is going to be take off a very small amount of material to leave my surface finish looking really nice. I'll leave the other options like they are. Linking parameters is where you tell the tool what I need to do going vertically down to make my cut. And so Again, depending on who you ask, some people will say that they love the incremental, some people will say they love the absolute. To keep everybody doing the same thing, I'm going to just choose absolute everywhere and ask you to do the same thing. The other one, incremental, it moves it incrementally from the last spot it was. So you can keep track of incremental moves. If that's the way you like to do it, then you can turn it on incremental, and I just like to use absolute. So for sure we want the top of stock to be 0 because that's where I define the top of the stock, top of the part. This is feed plane. This is where it starts. When it goes down to this level in the Z direction, it's going to start using the feed rate that we assigned with the tool. Retract is how far it goes all the way up before it starts. So I'm going to leave that as a quarter. That means it's going to start off quarter up. It's going to go down to 2/10. Then it's going to start feeding it at the feed rate. When it gets to the top of stock, that's when it's going to start cutting. And I want this depth to be 28 thousandths in my case. Yours is going to be different. And if I type in 28 thousandths, that's going to be incorrect because it's going to be positive Z028, and it's not going to cut anything. So these depth cuts, if you've got the top of the stock at 0, these numbers are always negative. So maybe I'll leave that like it is. Coolant, we're going to always want to turn on flood for the coolant. Keep our tool and the chips and the part nice and cool and lubricated. And I don't know, maybe I've done enough here. I want to see what happens. So I'll say okay. And then Mastercam goes in and implements my tool pass. You can see the lead in and lead out. You can see the helical going into the part, and it's zigzagging back and forth. And so I don't know, it looks maybe reasonable, but let's save this thing since it seems like I got something maybe worthwhile here. I don't want to lose it. The power goes off. So I'll save this. Now I'll say I want to do a simulation. I want to run the simulation. So I want to select these buttons here. You're going to be using these a lot, and you have to get used to what these pictures mean. So just hover over them. Don't click it. Just hover over them and see what it says. This says select all operations. And so when I do that, it'll select all these machining operations. And right now I've only got one. But I'll hit select all, and then I want to hit this button right here, verify selected operations. So when I do that, it's going to bring up a new window, and it's going to show me step by step what my code will be wanting to do when I do the real part. And so I'm looking at my other screen here. This thing popped up on this other screen. Let me drag it over here. And for some reason, this is showing my other part. It's interesting. There we go. So this is good. So what you can do is you can, there's lots of options up here to turn on and off things. I'm going to just go through a couple of them here. These stop conditions, I like to turn it on for operation change, tool change. If we have vices and other parts of the HAAS machine modeled, we can turn on these collision events. But we don't really have a lot of things in the way. The vice is always below where we're cutting, so I'm not going to turn those on. So I'll leave it at that. And then I'll just run this thing. So I want to slow it down a little bit so it doesn't zip through it too fast. And I just play it like a movie here. So let's go play and see what happens. So it goes down, leads in, and for some reason it doesn't seem to be cutting anything. So I wonder if my stock is not in there. I think that might be the problem. My stock is not showing in there, so maybe I'll speed this up. Yeah, so it didn't do anything because my stock is not in here. Am I showing the stock? Yeah, I'm showing the stock. Maybe it never did implement it. So let me get this thing closed. This is a separate window. Close it, I come back here. What happened to my stock setup? That's what I want. Why was it not there? Cylindrical. I'm not understanding why it's not taking this one. Some of you smart guys out there will remove that. Maybe I had two options, I had the wrong one checked. So let's try this and say, okay, that looks right. Anchor points at the top, starts at 0. It's hard to see. Well, I think it's in there. All right, let's try again. So I'm going to save this thing. File, save. And let's go run the simulation again, see if it's got the stock in there. Now it looks like it has a stock because I can't see the part because this is the full raw material. So maybe this is it. So let's go slow this down again. It's going down. Does the lead in. It's going back and forth. So this looks reasonable. So that's the depth, first depth cut. And it looks like it's doing well. It goes up. Now it's going to go back down again and lead in. Now it's cutting a little bit deeper. Or it's cutting those edges, cutting those walls. Now it's going to go retract. And it made 2 passes, I guess, to get to the bottom. So that looks like that did that correctly. So let's close that up. Now let's talk about the next feature. I want to drill a hole. I want to drill this 16th inch hole through the middle. So I've got my first tool path, and I want to make another one. So I'll go to tool paths, and I'll go to drill. And it's going to ask me for some geometry. And so I want to move this out of the way. I'm going to go select this center hole here. So I'm going to hover over the circle. And I'm selecting that point right there. And I think I got it. So I'm not using the geometry of the hole. I'm just using the center of that circle. And then I want to tell it in a minute what size drill to use. So I'll approve that. So now I've got the geometry defined. And now I need to do the same thing as I did before, which is say, what tools do I want? Answer those same questions. I'm going to go to the, oh, look at that. It selected an 1/8 inch drill. It thinks what I want. So I'm going to go find my drills. Oh, my light goes off. Light comes back on. 16th inch drill. I've got looking at my drawing here, 16th inch drill. That's what I want. Adds it to the list. Again, we'll have to change that tool number to match what it was on the HAAS. Well, I thought we'll have to revisit these feed rates and spindle speeds. We'll do that in class. Cut parameters. I want to drill. I can do peck drills, and we'll seem like a good idea to do a peck drill where you go down, drill a little bit, come out, extract, let the chips come out, and go down, 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 and go all the way through eventually. So we'll leave that like it is. I want linking parameters. So here it's defaulted, so the retract is 1/2 inch up, and these need to be all absolute if you play by my rules I said earlier. So I'm going to turn all these absolute. Top of stock is 0. It's going to start 1/2 inch up. In the depth, my part is 1/4 inch thick, or 1/4 inch below the top of stock. So this number needs to be -1/4, but I want it to go a little bit past the bottom, so I'll make sure I get a clean, full diameter all the way through the part. So I might make this depth, instead of making it a -1/4, maybe I'll make it -0.375. That way it'll go all the way through plus a little bit. And you've got this temp compensation thing that does some calculations, but since it's a through hole, I'm just going to choose a little bit deeper than the whole part, so I know that'll go through. So maybe I'm happy with that, and I'll go to coolant, and I'll turn that on, and I think maybe that's all I need. If I forgot something, it's okay. When I do my simulation, I'll see it and can fix it later. So I don't know. I'm kind of nervous about checking to make sure that looks right before I move on, so I'll do the same thing. I'll run my simulation, and maybe I'll speed this one up a little bit because I already know that it works, or I know what it does. So there's that, and it's kind of fun to watch, but I'll speed it up some more. Okay, now it's switched tools. Now it's got my 16th inch tool, and yep, there it is, a twist drill with a little point. And I want to go zoom in here, and I want to run this one and see what it looks like. So it goes up, it It goes down, it pecks, it comes up. Maybe I could have it not retract so far because it's pretty high, but it went pretty fast there. Let me slow it down, rewind it, play it again. Did it so fast I couldn't hardly see it. Rewound it too far. There's that one. Going up. It almost looks like it didn't do a peck. Let's go back and look at that. So I'm going to come over here, drill, parameters. What did I miss? Cut parameters. Linking parameters. Somewhere I'm not telling it to do pecking, and so I'm going to give up and let listeners give me some comments down there and tell me what I'm missing, but I don't think I'm doing peck drill unless it's going so fast I can't see it. I thought I'm doing it because of this parameters here, and linking parameters. Maybe I'll make this number a little smaller. That doesn't matter with the pecking. All right, I don't know what I'm missing, but we're going to approve this, and I want to save it again. And maybe I'll do this counterbore hole, and we'll call it good. So this is going to be, these 4 holes are the countersinks on the other side. So I need to do a drill on these based on the size of the clearance hole. So you'll find the right tool to do the clearance hole on these guys. And let's do this counterbore, and then we'll call it a day. So I'm going to go back up here to Tool Pass. I'm going to do another drill. This time I'm going to find the geometry. So I'm going to come over here. I'm going to hover over the circle, and I want to select that point right there. There's one. Hover over the circle. Grab the center point right there. Excuse me. Do it one more time over here. There's the center point right there. You can see the little indicator that Mastercam gives you when it's on top of the thing you want to select. It gives you a little indication. So right there it sees that center point. So now I got those 4 holes located. Actually, that's the wrong one. I want these counterbore holes. So I'm going to delete this one. I'm going to add this one and then delete that other one. So watch what you're doing. Don't do as I do. So this one's the wrong one. So I'm going to right click and see if I can't delete that one. There we go. So now I think I've got the 4 center points. So I say OK. And now I need to go to tool. I need to find a counterbore tool. And so this is one that is not on our list. It's a counterbore for a number 4 socket head cap screw. And there's not one in the Mastercam tool list as I remember. So I'm going to come down here to drills. There's some taper tap, reamers, counterbore. It's got counterbore for a number 6 cap screw, but not for a number 4. And so that's a problem. We're going to have to build a special tool to mimic this counterbore that we're actually using. So but for now I'm going to use this. And remember, I'm going to have to go change the parameters of the tool later. So this will give me something to start with. So I'll say OK. And I'll do as I did before. I'll go to cut parameters. I'm going to try to do another peck drill. Oh, there's my problem. I didn't choose peck drill. No wonder it didn't do a peck. So let's choose peck drill. Now it's going to use those parameters. So I can fix that other one in a minute. Linking parameters. These are all absolute, so I must have remembered my last choice. Top of stock. This is going to be that same. It's going to go all the way through, so I'm going to make that negative 0.375. And maybe that's all okay. And then coolant. It's remembering that I want the flood on, so it's already got that. So maybe I'll say okay. And now that I've figured out why it wasn't doing the peck on the other one, I'm going to go edit this other tool path. So I'm going to come up here to parameters and go to linking parameters. No, where was it? It was under cut parameters, boom, pec drill, okay. Now when you make changes like that, you've got to rebuild this thing, rebuild the toolpath. So I'm going to select all operations, and I'm going to click regenerate all selected operations. So if I would have moved a whole location, if I changed that pec drill from no pec drill to a pec drill, I always like to select all operations and then regenerate all of them, and that just regenerated all those toolpaths. So now I'm going to save this again. Whoops, I want to make a new one. I want to save what I got. And now I want to do another simulation. So I'm going to select all operations. I'm going to go to verify selected operations. And let's keep our fingers crossed and see what happens. So I've got it slowed down quite a bit. Let's play. This is my 1/4 inch end mill, flat end mill. It's got the lead in. Maybe I want to change that. Maybe I don't. Let's leave it like it is for now. So that's going in with that first depth cut. And it does that. Now it's going in to do the second depth cut. This is I believe this is the finished cut. It's going around doing the pocket. And it's done. Now it's going to do that 1/16 inch drill in the middle. I'll hit play here and see if it doesn't do the pecking. So it's going down. It pecks. It pecks. Pecks. There we go. It's going down. It's going down. Going down. And there it's all the way through. So it looks like it went all the way through. Now I've got. Is that it? No, I got the next. Going to the next operation. So I'll play this. Oh, you know what? It's doing that counterbore. That's not what I wanted. I want to do the clearance hole first and then the counterbore, because we've got that little bit on the end of the counterbore tool that's going to guide it into that hole. So this is not what I wanted to do. I got the order wrong. I need to change this to the clearance hole pec drill. I don't want to peck on the counterbore. So this is going all the way through. So this is not correct. That's not the right tool. So that's okay. It's done. I can get out of here. And let's go fix it. I got to go change this thing here. Go back to parameters. I need to change the tool from not that counterbore. I got to do the clearance hole first. The counterbore tool makes the counterbore, and it assumes the through hole is already there. So I screwed up on that. Let's go fix it. I need I'll look at my tool list somewhere in my stack here. That tells me that tool is a 129 diameter through hole, I believe. So let's go find drills. 129 drill is what number? Hidden right here. 1285, that's 129. It's a number 30 drill. That's in our tool list. That's what I want. And I've got cutting parameters, see if those are still, or linking parameters. It's still going to go all the way through plus a little bit. So I think that's correct. So I'm going to say OK. And I want to select all. Shouldn't have to regenerate them, but I will anyway. Select all operations, regenerate operations. That was probably not needed. Let's go to verify selected operations and run through this one real fast because I already know it works. Boom. I'm going to slow it down. Do that middle hole. It's pecking down. I probably could have that retract not so high, but it's going down. It's pecking. It pops all the way through. And that one's done. Now we've got the twist drill with a point on the end, and let's play this one and see what it does. So that's going to peck up and down, and I'll speed it up a little bit. So it looks like it's going all the way through. Now I've got my clearance hole. Now we're ready to do the counterbore. So that was that one. I'm going to do one more tool path. I'm going to do a drill. I'm going to go grab the points. It's the same points we chose last time. So I'll do the same game. I'll select that center right there. And I'll select that center right there. And 2 more. All right. 1 more. Boom. So there's my geometry. All 4 points. Tool, now it should be on the list already. There's my counterbore tool, the one we're going to have to fix, but we'll use that one for now. And now I'm going to tell it go to parameters. I'm going to change I got to change. This is not going to be a pec drill. It's going to be just a plain drill. Linking parameters. I want to go down. This is going to be the depth of my counterbore. And the depth of my counterbore is whatever it is. And that better be a negative. So we'll have to make sure we set the tool up so that the top of the cutter for the counterbore is at 0. So that'll make the counterbore depth. And your number will be different, potentially, because of your different hole sizes you may have. All right, so let's approve that. And now I think I've got everything I need. So I want to save again, make sure to save off, and let's see if this might be our last run here. Let's see if this looks decent. So we'll speed it up, run through that, boom, run through the next one. Stops after every operation because I got those checked on. Let's slow it down a little bit to relive the glory of these clearance holes for the counterbore. And as you're watching, you can see over here it's giving you information about the estimated time it's going to take to make your part. So this will give you an idea how much time will be used cutting on the HAAS. That looks like that goes all the way through. Now let's see what this counterbore looks like. Play that. So if I did the tool setup right, that counterbore depth is at the correct depth. So we're still missing the last set of holes, but that gives you an idea. We've still got a lot of work to do. We've got to come back in here and change these tool numbers so that they match our tool. Identifiers that we have on the HAAS. We need to visit the spindle speeds and feed rates we talked about in class, and those are controlled by this feed per tooth value. We're going to change that one based on our material, the tool, the number of flutes, those kind of things. And then the surface feet per minute is going to be the other parameter that'll set that spindle speed. But we'll leave those now. So maybe that's enough for now. I'm going to save this thing so I can fix it and move on when I do the other changes to those parameters we talked about. So hopefully that helps you get started. You can tell I'm by far away from being an expert or even being an intermediate user of Mastercam, but it's not too painful. So hopefully this helps and gives you on the right track to start making your first set of tool paths for our HAAS machining. So until next time, have a good day, and we'll talk to you in class.